Hello everyone. We stopped the last video at this point. Before that, I want to again introduce myself. I am Dr. G.L. Karthik, Assistant Professor, Department of Biomedical Engineering, SNS College of Technology, Coimbatore. We stopped at AlexNet. So this is the architecture of AlexNet. So it does 5 times of convolution process, right? We are able to understand that when we do more and more convolution, then we filter out more and more data. But what is more critical here is what type of a kernel or the filter matrix that we are using, which will be running over the input matrix. Both will input matrix and kernel will be convolved, and then we will get the output matrix, which will be the features extracted from the input matrix, right? Now this is the table that gives information about AlexNet. So here we can see the layer information. First input convolution is taking place, then max pooling, again convolution, max pooling, 3 times convolution, max pooling. Then we have 4 fully connected layers. So we can see feature map 196, 96, 256, 384, 384, 256, 256. Then here also we can see that the size of the matrix is reducing because we are filtering out. So the size of the matrix is reducing, and then we get output as a single value like 1000. Then even we can see kernel size, what it is actually used. Starting 11 into 11 is used, then 3 by 3, then 5 by 5, then strides. What are the activation functions used here? They are using ReLU activation function, then at last using the softmax activation function. Fine. Now next we will now see about VGG net architecture. It is the another architecture. Okay. So while prior AlexNet derivatives focused on smaller window sizes and strides in the first convolutional layer, VGG takes a different approach. VGG takes a different approach to CNN. It takes input as 224 into 224 pixel RGB image. To keep the input size consistent for ImageNet computation, the authors clipped out middle 224 into 224 patch in each image. The receptive field of convolutional layers is VGG is quite tiny. So in VGG net architecture, the convolutional stride is set as 1 pixel in order to preserve spatial resolution after convolution. VGG contains 3 completely connected layers, the first 2 of which have 4096 channels and third of which has 1000 channels, one of each class. Due to its adaptability for a variety of tasks including object detection, VGG CNN model is computationally economical and serves as a good baseline for many applications in the computer vision. So this is the VGG net architecture. So what we can observe in VGG net architecture is it starts with the 224 into 224 into 3 pixel, right? Why there is a 3 as the third term here is that 3 represents RGB image. Here color image is taken, and then the pixel is reduced. We can see size of the image or the matrix is being reduced. So then convolution takes place here with the input image. Then here max pooling is done. That orange color box is it represents max pooling, and then there is a fully nected or ReLU function is used as the activation function here, and at last we get one row right, one row pixel, 1 into 1 into 1000. So it is reduced to a single value pixels. So we will continue about this architecture in the next video. Thank you.